We're going to talk about web development workflow. Because I think over the past 2 years in particular, there's been a lot of tools that we've gotten as developers to increase our productivity, reduce our stress, and putting them together in a kind of a workflow that makes sense has been an interesting little challenge. So I'm going to walk through kind of what my approach has been, what I've seen other developers doing. So start off, Brendan Ike actually brought this up in his talk yesterday, where he brought up this quote from Rebecca Murphy. We're seeing the emphasis shift from valuing trivia to valuing tools. And I really like this. I do think this is from Rebecca's post where she set out a baseline of knowledge of what front-end developers should know or should be actively learning. And so she was pointing out that instead of having to keep track of all these browser incompatibility issues, we're getting a chance to really let tools do some of that work for us, and we're getting to ratchet our attention up the abstraction stack and kind of use these tools now better. And then another quote, this is from Rand, who's an engineering manager at Apple, said this: as an engineer, there's a short list of tools that you must be rabid about. Rabid, foaming at the mouth crazy. And I really like this. He goes on to talk about his text editor, his terminal, and says, like, this is where I spend my time. I care a lot about them. Any engineer worth his salt should care a lot about them and should be a zealot for the customizations that he has in there. So we're going to go through a few of these things. What I want to start out with is the shell. And so we're going to kind of walk through from kind of start to finish what the workflow is. In the shell, well, as a few recommendations, I think you should make it sexy. You feel good typing in your shell. There's a great community on GitHub where people share their customizations in .file repos. And there's a lot of recommendations and tricks you can learn from joining this community and picking up some of their .file customizations. I have a few favorites that I use in my shell, so I'm just going to bring those up right now. All right, so we're just going to bring this down here. And the first is a little jumping script called Z. And so I'm going to jump over to my HTML5 Please repo. So I can just type Z and then any portion of that name, like please, and we jump right into it. Similarly, I could just jump over to my Modernizr project and type out any portion of that name. Or I'll go back, let's see, Modernizr, yep, or go back to HTML5 Please. So that works nicely. The next one is to launch a server. I type server, no big deal. We bring up a server. What's going on here is that we launch off a simple Python server at defaulting to port 8000, but I could specify my own port. And we open up a browser tab with that address as well. Works well, easy peasy, sounds good. All right, moving on to the editor. I don't really have any particular recommendations as far as what your editor should be, but the recommendation here is just to learn it well. A good editor is an onion application. So as you use it, you get to peel back the layers, reveal more functionality. And an editor is where, more than any other tool, where you should be focusing your time learning new tricks, augmenting it with packages and plugins, and really prioritizing that as the thing where you're getting to know it very, very well. So I'm going to bring up my editor, and I have a little alias to bring it up, Sublime Text, and I'll bring up a script file for this project. Now, one of the things that completely changed how I'm authoring JavaScript is having real-time code linting inside the editor. So you can see it here, these white boxes. So in this case, we have a white box around this area. And if I zoom in down at the bottom, we're seeing I is already defined, len is already defined. If I look, OK, my var I len, yeah. Oh, OK, yeah. So in this case, I have two loops. I'm reusing the same variable names. And because of variable hoisting, these variables are actually conflicting. In this case, it's not terrible, but I should probably clean that up. But I like having real-time feedback. And so scrolling down here, we have a few assignments going on. And I kind of don't like doing multiple variable declarations, though I know a lot of people that do. So I'm going to refactor this just a little bit, throw that to comma, do a multi-line selection. And that's good, but all of a sudden, I now have some more white boxes. OK, cool. Looking down at the bottom, H2 is not defined. Huh. Yeah. So this is something that I normally probably would take a little bit to catch because I have a semicolon there instead of a comma. Now, this would have worked fine in the browser, of course. This would have been an implicit global. But that's not what we want. So getting that feedback as I'm typing has been dramatically changing kind of my workflow. So the way that I look at this is that code linting is your first unit test. Typically, when you're writing unit tests, like the first one that you end up authoring is something like, is the global there? Is the module defined? But even before that, does the script compile? And we can use static analysis to kind of give us some feedback real time on that. So I think having real-time feedback is an important thing. And we've been seeing a lot of tools lately that kind of give this to us as we're developing. So we just looked at live linting, but we also have live recompilation and live reload. So I'm going to show some of that now. So if I bring back up HTML5 Please, I will show my editor as well. And we'll bring up my style sheet. Now, my style sheet here is just less. Sorry, it's a SAS file. And I'm going to skip down to my headline. So just to make sure, I'm going to trigger off my live reload extension. This connects it back up here. And now, just to make sure that this works, I change my text shadow to 41 pixel offset. And indeed, it changes over there. Cool. It's good. Now, I think we could do with a little bit more excitement over here. So I'm going to just add a hover state. So let's see. We'll add a text shadow of 1 pix black, and a nice CSS transition. Cool. And 0.3 seconds. That sounds good. Save the file. And now I just go over, don't even hit refresh, and I have this new behavior inline. So this is really cool, getting the compilation, the live reload of the styles as I'm typing, so that I'm not going back in a loop, hitting F5 every time I'm making changes. Now, coming back to JavaScript. As you're scaling out a project, you often notice that it probably does not make sense to type your entire application in a single script.js, but instead it makes sense to break it up. So this is important just for you as far as developer ergonomics, but it allows you to use a dependency management system to kind of structure what is the relationship between all these modules and how am I going to compile them into a single file or a few files when I go out to production. So you have a few possibilities here. You can use AMD modules. You can use common JS modules, typically used in Node, but they can be used in the browser as well. ECMAScript Harmony has modules as well. And there's a few people looking at authoring in those modules and then maybe transpiling into AMD to run in the browser in development. And then, of course, when we ship out to production, we're going to remove all those modules, collapse it into a single file for that optimized fast file. And there's another one that I wanted to show really quick. So in the Ember.js project, they use a technique here. So this is just one of the files inside Ember.js. And we have a require statement. So this differs from common JS modules, where this is not returning a single object. This merely just says, hey, go grab this file. Make sure that you evaluate this file before evaluating the rest of this. And it actually does this using a very cool technique using a feature called source URL, which I'm going to show in just a moment. There's a few tricks and techniques when you're doing dependency management and working with templates, for instance, that you should keep in mind. Using something like pre-compilation, so that, let's say, you're bringing a template into a view. You can require that template in as text, and that's good. But handlebars, for instance, it's about, I think, 34K but the handlebars runtime is about 2K. You don't need to ship all of handlebars.js to your users. So you can make sure that you're pre-compiling all of your templates into functions in a build step, and then shipping out the compiled templates along with just the runtime for a very fast experience. You can also do custom build output based on forking. So let's say this is from the Required.js optimizer, which you should definitely be using if you're using Required.js. So here we just have some application code, and we're forking based on this. Now, with Required.js, we can actually say we're going to create a custom build profile. And so let's say we're going to create a build profile for mobile. Now, for this has something, we could say in our build profile that something, maybe it's touch instead. And touch is true. So we're going to create a custom build assuming that touch is true. And the optimizer will actually go in and rewrite your code to just leave the Boolean there. And so then when this goes to Uglify or Clojure compiler, we can just wipe out this entire section with dead code removal, and it never even ships into production. There's a really excellent deck from Alex Sexton, who gave a talk yesterday at BackboneConf over in Boston. And I encourage you to check this out. It covers a lot more magic with dealing with templates, build systems, and modules. OK, cool. Package management is something that in a year from now, we're going to have a really robust package management tooling infrastructure and a lot of packages in the community. Right now, it's kind of still finding its footholds, but we'll be seeing some more things coming out soon, I think. In the browser dev tools, there's a few features that I want to show that really give you power when you're developing large applications. The first is source URL, which I mentioned when I was talking about Minispade. So this here is a short demo. This is, we have some CoffeeScript running right inside here. Now I'm just going to change a little bit this to expose a global. Cool. Now, normally, when I execute this CoffeeScript, this goes into CoffeeScript.js. It creates the JavaScript, and then it'll take that as a string and eval it. Now, normally, if you just eval text, let's say console.log, hi, everyone, it disappears kind of into the ether and doesn't show up. But with source URL, we can do something different. So I hit compile. And over here in the Chrome DevTools, I now have it kind of showing up as a real file. So this was just evaluated as text, but at the end of it was a source URL definition. And this says, hey, treat this as a file. We have support for this in both Chrome DevTools and Firebug. But the cool thing here is that this acts pretty much like a real file would. So I can set breakpoints. And so we'll just run cube 5. We hit real breakpoints. And I can even do my live reload inside the Chrome DevTools, too. So I'll return 1 from the square function instead. And now, instead, I've changed my behavior. So I get a lot of power. And this is really powerful when we're taking in any sort of dynamically generated functions and acting on them. The next is source maps. Now, if I come back to HTML5 Please and I view source, I'm going to go down to the bottom. And you'll see down here, normally I would have something like these 4 files. In this case, I don't have a dependency management system set up. I just have these loose script tags. Not great, but at least I've taken care of that in a build step, and I'm including just the minified file. Now, normally, you would open up Chrome DevTools, and you'd see that one minified file, and you'd be like, this is a mess. But in this case, we actually have the original source files. And this is because we're using a source map to take that minified script and map it back to the original sources. So this is really powerful. I can, let's say, I'm just going to navigate to this click handler that I have defined down at the bottom and set a breakpoint and click into it. And so we have actually, so right now, Chrome DevTools, the browser is interpreting minified compiled JavaScript. But the DevTools are mapping it back to my original sources so that I have full debugging, full breakpoint debugging with a live console. It's pretty powerful stuff. All right, so moving on to mobile. There's a few ways to go about a mobile workflow. I test in Chrome. There's a lot of features now that let you just kind of stay inside the desktop browser. So first, I have my DevTools set up in dock to write mode. And this lets me actually change the size of my actual site or app and see whatever my media queries are doing to it. But there's a few more features that I wanted to show. I can emulate touch events. So if I have anything that's specifically bound to touch start, touch end, touch move, all my clicks are just mapped over to that. And I can also override the user agent. And this happens at the network level, too. So let's say that I wanted to make requests pretending like I'm the iPhone. I could do that. I can also override device metrics. And so this actually gets populated as I change my user agent. So here is iPhone, and here is Nexus S. And I'm actually able to see exactly the resolution that this will show up in here. And any sort of device media queries will be caught and work as well. So this is pretty good. But sometimes you need a little bit more. You can run emulators client-side. You can also run emulators in the cloud. BrowserStack has added a number of mobile emulators to their lineup. And you can check those out there. Other times, you'll have real devices. And so I have a Kindle here. I have my Nexus S. And I've been using Adobe Shadow a lot lately. And with Adobe Shadow, you basically get, just as you're moving around inside Chrome, your devices are following after you. And this is a really powerful setup. And I'm just going to pull up one of those right now. So here we have this guy. And I'm just going to make sure that I pair this well. How's that sound? Cool? Good. Now I have my phone. It's tracking my movement across these pages. And that's really nice to kind of just have it sitting there on the desk as you're working and your device is following along with you. But sometimes you want to go a little bit deeper than that. And you want to run with the real DevTools. With Chrome on Android, you can do that. And so you get full DevTools power, CPU profiling, memory profiling, the timeline, everything running inside the mobile environment. When it comes to testing, I recommend to author in whatever you're most comfortable in. Writing tests may not be the most fun thing in the world, so optimize what you can about it. If you like the conversational kind of feeling of writing assertions in Jasmine, go for it. The more strict assertion style of QUnit, that's cool. But there's a few places where you can run tests. First, in the browser, right? So this is normal. This is the HTML5 Please test suite, simplified, running inside QUnit in the browser. It runs. It's good. Cool. Next, I could run it in a headless browser on demand on the command line. So here, I'm just going to call up grunt and say QUnit. And what this is actually doing, it's running, grunt is calling up Phantom.js. And this now just runs a headless WebKit and pulls up those QUnit tests and reports back to me that this did succeed. I could also run in a headless browser post-push. And so this is something that we do on the Modernizr project. After every push to the repo, Travis just picks up our files, and then runs the QUnit tests inside a Phantom.js case, and makes sure that on every commit, we are indeed still staying green, which is really nice. But we can get even a little bit better. We might like to do multiple browsers via the command line. And so to show this, I'm going to bring up Bunyip, which is a new utility from Ryan Seddon. So over here, I'll type Bunyip and call that. And so we create a little hub using Yeti. I'm going to go to this. And now we actually had two agents connect, both Chrome and my phone, right? And so now I'm actually just going to disable shadow because it's been doing so well so far, but this part it gets a little tricky. I hit enter, the testing starts, and my desktop completes, and it looks like my phone is taking a little bit longer, but pretty soon it'll complete as well. And so I'm able to manage a lot of local devices and report back on the command line. That's pretty cool, but we can also do a little bit better than this. We can run in multiple browsers in the cloud via the command line too. So with Bunyip, it's almost the same, but I'm going to use browser stack. So in this case, I'm like, hey, browser stack, give me 3 iPhones, give me 3 iPads. Pull them up, run my QUnit tests inside of them, and that's it. So this is really exciting stuff. I'm not going to wait for browser stack to return its results, but I'm able to just test my code against these emulators in the cloud, which is really cool. All right. In a build system, there's a lot of things you got to keep track of. Things like a lot of the things that you've heard from Steve Souders over the years, but in a JavaScript application, it gets even more complicated. So keeping track of all this is really tough. And my recommendation here is to use Grunt. You saw what I did when I pulled up, when I ran Grunt QUnit. So this used a Grunt task to pull up Phantom.js, which is a pretty complicated headless WebKit. And it was really easy for me to manage. And the cool thing about Grunt is that there's a number of tasks that are kind of being collaborated on by the community. So instead of creating a make file for every project, you can just grab these tasks, pull them together, configure them for your structure, and really benefit from what the community is doing. The other thing I do want to point out, after you publish and deploy something to production, you're not done. Client-side error tracking is something that I think we all overlook, but recently I've been getting more into watching this. There's a great project called Errorception, and I added it recently to a web app that I somewhat hastily put up, and got a very nice report of all the JavaScript errors that I was exposing in production. You can see IE9 is catching quite a few of them inside of this. Looks like my application cache. But getting this kind of report is really quite valuable. All right, there's a lot of stuff, a lot to keep track of. But there's a few projects that kind of manage some of this complexity for you. I've already shown you Grunt, Library Load, Adobe Shadow. CodeKit is a great GUI that manages quite a bit of this sort of stuff. Brunch is a recompiler to kind of watch anything that you have written in any sort of templating language, CoffeeScript, Sass, Stylus, anything. And the WebStorm IDE from JetBrains is a great project that captures a lot of this type of unit testing, code coverage type integration. In summary, should reduce friction for the sorts of things that you should be doing, like testing. But really, any sort of repetitive task, make it easy on yourself. Don't repeat yourself is something that we hear regarding writing code a lot, but it applies to using tools too. You shouldn't type build.sh every time you save a file. You don't need to FTP something every time you update a site. I recommend you sit with another developer, just look over their shoulder, learn from their workflow. Maybe offer some tips that you know. Kind of make it a more collaborative experience. And when you find a workflow that you like, blog about it, make a screencast. There's a lot of people trying to figure out what the best workflow for mobile debugging, mobile development, web app performance improvements is. And so I think we should talk more a little bit about this. Anyways, I hope that was helpful. Thank you guys very much.